across Scotland has a set of at least 20 microbits. And some of you might have even signed up last year to receive another 30 from the Microbit Next Generation project, which was specifically for primary schools. But every single school, primary and secondary across Scotland, has at least 20. So if you haven't seen them, go hunting for them. They'll definitely be in a cupboard, in the office. I've come across some that are still not opened. But for those of you who are new to the microbit, it is literally this size. It's a pocket-sized computer designed to make coding and digital creativity accessible and fun. You can customize it and use it to bring your digital ideas to life. It has buttons, LEDs, sensors, and even radio communication. It is perfect for exploring coding and robotics, and can all be done extremely simply. We'd be really interested to hear about your own experience with Microbit. We have added a wee poll here to gather this information.
So you'll see it's on the right-hand side of that frame on the Miro board. And if you can select your experience with Microbit, that would be really useful, just so we've got an idea of where we're coming from.
Okay.
Okay, so some people have used it a little, and that's fine. There are actually currently 2 versions of the Microbit out there in the world. Version 2 has more features. It has a speaker and a microphone, a touch-sensitive logo, and a more powerful processor. You can actually tell the difference between the version 1 and version 2 microbits in a couple of different ways, but by far the easiest is just to have a look at the back left-hand corner. On the V2 microbit, it actually says V2 right there. So let's have a wee look at a video showing the key features of the V2 microbit. All the videos and resources we show you tonight will be available for you to come back to after the workshop. So if it feels like this is information overload just now, you can revisit later on.
From phones and tablets to music and sport, digital technology is everywhere. It entertains us, helps us to communicate, find information and shop for things
Video is
we
not
need.
playing for me, so if somebody can tell me when it
Understanding
stops.
technology can affect our goals, dreams and ambitions. If I love chatting to friends and sharing moments, then I can design and build technology for me and my friends. The BBC Microbit is designed to inspire young people, providing the key knowledge, understanding and skills to become creators, not just users of technology. The latest version of the Microbit has all the features of the original and some fantastic extras, so you can learn and play in new and exciting ways. It has 6 sensors: motion, temperature, light, magnetism, sound and touch, as well as wireless radio communication, lights and buttons. The microphone responds to sound and measures noise levels. It can even detect when everything's quiet. With a speaker, you can play the sounds you create instantly, making it easier to add music to your inventions. The Microbit logo is now a touch sensor. You can program to react to your touch to build even more exciting creations.
That's probably it, isn't it?
The BBC Microbit
And that's
is
a pretty
small,
impressive
but
bunch of
mighty.
features from such a
What
teeny
will
weeny
you
device,
create
don't you
today?
think? We used the online Makecode editor to create code for the Microbit. So I think we're going to have a wee look at the Makecode editor right now.
Yeah, no precinct there.
Let's just join back into the presentation while we move on. Yep, okay, so this is actually a free online website. There's no installation or login details necessary, so it's absolutely perfect for using in your classrooms. On the left-hand side, you can see we have the simulator. So this is when you don't need an actual physical microbit, because you can create code and see a live microbit preview that instantly shows what the code will do. And it's perfect for testing your code before downloading it onto your microbit. Next to the simulator is the toolbox, and that's just categories of color-coded blocks, which will be super familiar to anyone who has used Scratch before. My dog has just jumped up on my back. Then on the right-hand side, we have, sorry, excuse me one second.
My dog loves the Microbit, loves one.
She does. She's brought me her giraffe. Is this your giraffe? This is your
Oh,
giraffe.
worse.
Oh my gosh. Sorry, people. Sorry. Oh, she just, I sit on a ball, not a chair, so she likes to jump up. Sorry about that. Next to the simulator, I told you about the toolbox, which is categories of color-coded blocks, and that's pretty much the same as Scratch. Then on the right-hand side, there's the workspace, and that's where you're going to drag and snap together all your coding blocks to create the program and bring your ideas to life. At the top of the screen, you'll see a sort of switch button that says blocks and JavaScript at the moment. And if you click on that wee down arrow, you can actually switch over to Python. And that's where you can switch between block coding and text coding. And sometimes I have a wee look just to see what my block code looks like in different coding languages. And certainly lots of the pupils that I've worked with love to see the text, what the text-based coding looks like. And of course, at the bottom, you can see the download button, which does what it says on the tin. It downloads the code. Once you're happy with your code, it can be downloaded onto your microbit. How you actually do that, how you download or flash the code to your microbit, will look slightly different depending on the devices you're using, whether it's a laptop, a Chromebook, an iPad, or whatever it is. But thankfully, there are some brilliant guides embedded in the Miro board showing you how to connect your microbit. And in the bottom right-hand corner of this frame, that's actually a thing link that's just got that information embedded into it. So it's either drag and drop or direct flashing.
Now we have a frame here in Miro again with some post-its for you to add any feedback or questions that you might have about the features of Microbit and Makecode. Amanda is our Microbit expert, so if you have anything, she is the lady to direct your questions to. So we'll give you a couple of minutes just to add anything.
So I can see Ryan's posted that the V2 sounds great, but what if a school only has V1s? Are they left behind? No, they're not left behind. You can still use the V1s. The V1s still work brilliantly. They just don't have as many features as the V2. But I promise you, your school will have at least 20 V2 microbits. These were sent out by Education Scotland a couple of years ago, and they went to absolutely every single school in Scotland. So you definitely have at least 20, and then primary schools got the opportunity to sign up for an extra 30 last year. So I know in my local authority, I just signed up all my schools, so I know that every primary school has 30 in the building. You just have to go hunting. I promise you, you have them. Quite a few people have come and said, no, we don't have any, Amanda. Yes, you do. Go hunting.
And that's a good question there about keeping them ready to go. So the way that, I know everyone does it slightly differently, the way that I have them in my school is we have they're almost like little pencil cases with all the individual bits in it and the batteries and all that all in one thing, so they can just be handed out. And then those little pencil cases go inside a bigger folder, so that can just be grabbed and go. Some of the things can be finicky, so it's quite good to be able to keep them in the one little.
Yeah. In secondary, what we have, I just have them a class set of 20 in like a plastic wallet, and they're all numbered 1 to 20, and each pupil then gets a number, and we know then that they are responsible for that microbit number, so they know the bits they get with it, and they know that that has to be returned at the end of the class. So at the end of the class, you get the 20 back in the Polly Pockets, if you like. And because you've numbered them and a student's related to a number, if anything's gone missing, then you know who to pick on, and you know how to say, right, wait a minute, where are your batteries, or where is your USB cable? You know, you can ask that student what's happened to it. And normally maybe just dropped it on the floor or something like that. So it's quite easy to keep them together for the next class coming in.
Yeah, there's actually boxes and things you can buy that are purposely made to store microbits in them, but I've seen lots of people use different things, little plastic boxes, pencil cases, plastic bags, lots of different things. I would say once you've got the battery pack plugged in, I leave it plugged in, because trying to pull it out, we've had a few of our pupils that have just held onto the cables and pull, and then that's them. They're done, and the wee bit's stuck in the microbit. In my local authority, we've got these little rubber covers for the microbits, so we can really just to know the difference. But we actually had bought kind of hard plastic ones as well, so some of our schools have bought them. But microbits they're pretty hardy things. They're made for little hands. They're, I'm not saying you can throw them around, but they do take a beating and they don't tend to break very easily. I'm saying that, touch wood, please don't test it. But yeah, so they are made for little hands, and please use them. I'm just reading other things on. Is it
That's
best?
a good question from Annabelle as well.
Feedback here. Somebody said
Explore.
next steps for me personally is developing confidence with using them. It isn't just trying them out, and I hope the next part of the lesson will take you in a wee bit of coding. There's also one about letting children explore for themselves, and I think that's okay up to a point, but there does need to be some teaching to give them the foundations of computing science so that they can go further and understand what they're doing. I think there's a lot of kind of tutorials on there that kids can work through themselves, but sometimes
there's a really nice code that you can actually preload onto your microbit. I think it's like Meet Your Microbit or Introduction to Microbit, and it's a really nice one to ask your class to try and discover what they can about the microbit, about inputs. What happens if you press a button? What happens if you shake it? How many things can you discover that the microbit will do just using that code? But then, as Maggie says, you have to do the teaching. You have to introduce that vocabulary and those concepts so that once kids are great with ideas, but then they can actually bring those ideas to life.
I think the wonderful thing about the microbits as well, and doing the unplugged activity at the start, Annabelle, is it kind of like gets those concepts and you're actually talking about them without even going near something like a microbit. I know in the primary classroom it can be a bit scary when they go off and investigate and there's all these different blocks and I don't know what all of them mean. But I always give my kids a little bit of time at the end, once we've done the lesson, once we've introduced the concepts and created the project that I was planning on doing, to see what they can discover themselves. But it's with that sort of proviso of, if it goes wrong, I might not know how to fix it. And that's okay. We can discover it together, because I think it's okay to not know all the answers and how to fix it, as long as the kids are aware of that.
Definitely. Tinker time is always good fun at the end. Once you've got your code, can you improve it? What else can you add to it? What else can you do? Go and find something. So yeah, I would definitely recommend a bit of tinker time.
Absolutely. And I think when pupils see that you're saying, oh, I'm not sure, we'll need to sit and work our way through that. I think, that's they like to do that, like to work with you and solve the problem. So it's good learning on both sides, isn't it? Some really good comments and feedback here.
There is, like we said, there's absolutely tons of resources and tutorials out there as well. One of the things I've been doing Scratch with my primary threes, and there's like pathways and projects that you work through. So I will model it on the board and we'll go through it together. But on my iPad, I've got the next stage, so I know what's coming next. So it might look like, and it's quite a good support for me to know.
Yes.
And I can follow along, but the kids just think I'm amazing at it, so that's good.
Yeah, I like that. Somebody's made a comment, that's maybe Ryan or somebody, who said I like the PRIM method, and that's a really, really good kind of framework to use. That's just predict, run, investigate, modify, and make. So I've included that in your takeaway that you can have away today with you as well in the Wakelet. So there's a little graphic about PRIM model or the PRIM method. Yeah. These are all great comments.
They are great.